Hopefully everyone is doing well and are now second week together. Are there any questions on anything that we covered in the first week? Or questions on the homework? I assume by now everyone has joined the homework, created an account, and let's take a look. How many people have enrolled in the homework system? Because chapter 1, I think, is due, well, probably Thursday. So quickly, gradebook. I have, how many people is this? How do I tell? I don't know. Good question. Looks like a lot, though. So that's good. A lot of people have enrolled. I love it. 40 students. Seems about right. Chapter 1 homework, 15 of the 40 have completed it. Chapter 1 practice quiz, 7 of the 40 have completed it. So get to it. Wait, professor, I'm here. So that's Joseph Kim. All right.
I'm also here, Professor. It's Senna.
Senna. Thank you. Got you as well. All right. Okay. Well, in that case, let us continue with statistics. Since there's no questions so far, everyone's doing amazing. What's the book? I forgot. Is it Basic Practice of Statistics or is it the other one? This one, right? Basic Practice of Statistics. That's the one that we're using, right?
Yeah.
Excellent. I have like so many books here. Okay. So we had finished chapter 1. We had started chapter 2. And in chapter 2, we had covered the mean. We had covered the median. And we had talked about this concept of a resistant measure. So somebody remind me, please, between the mean and the median, which, if any, is a resistant measure? All right, so we have measures of center. Measures of center. So far, we have 2. We had the mean, and we had the median. This is a recap. And a couple of texts. What do we have here? I have median. I forgot what my question was. What was my question? Was it, which one is, what was it? What did I ask? Resistant.
It's a resistant measure.
Right, so the median is a resistant measure of center. In general, just a resistant measure. And the mean is a non-resistant measure. So the question then presents itself: in what situation would I want to use the mean? And in what situation would I want to use the median? So what we want to do now is talk about a comparison between them, a comparison between the mean and median. In other words, in what situations is it better to use the mean? And in what situation is it better to use the median? So in a situation where the distribution is symmetric, suppose, for example, I had a graph that looked like this, a famous bell curve. In this case, the mean and the median would be at the same location in the center. Because remember, a physical characteristic of the mean is the balance point. So if the graph is symmetric, it's a mirror image on one side or the other, then obviously the exact center would be the balance point, because it's the same on the left as it is on the right. And if it's truly symmetric, that means the median, the halfway point, is also going to be directly in the center. So if it's symmetric, then the mean and the median are both in the center. What if, on the other hand, it is skewed? Someone remind me, this shape, is it skewed right or is it skewed left?
Skewed right.
Skewed right. So what happens to the mean and the median if we have a skewed graph? What happens to the mean and the median if you have a skewed graph? So the mean, remember, is the balance point. So if I skew it to the right, what's going to happen to the mean? Is it going to stay in the middle? Is it going to go right, or is it going to go left?
Go left.
The mean is the balance point, right? So if it was here, which is where the peak is, assuming it was symmetric, if I draw a symmetric graph on this, so the mean for a symmetric graph is right in the middle. But if I skew it to the right, so if I have this long tail on the right side, where would the mean move to in this situation? Where would the balance point move in this situation? So I heard a guess, but unfortunately it was not correct. So I'll let you guess again. Or someone else. It moves to the right. The mean shifts to the right. The balance point shifts to the right. The median also shifts to the right. But which of those is resistant and which of them is non-resistant? Which is a resistant measure, mean or median?
Median.
Median, which means that while the median will shift to the right a little bit, the mean, well, that's quite the exaggeration. So let me be a little more accurate. While the median will shift a little bit, the mean will shift significantly more so. Of course, we need, actual numbers to get, exactly where we want to be. But in general, when you have a skewed right graph, the mean is going to be pulled to the right more than the median. And what if it's a skewed left graph? What do we expect to happen in a skewed left graph?
The mean and median would shift to the left.
But which one will be shifted more to the left?
The mean.
The mean, if here's, no, that's not what I want to do. If the mean is, if this was the original peak, the mean and the median shift, but the median does not shift as much. The mean will always be pulled further in a direction of skewness than the median. Does that make sense?
Yes.
Okay. So again, the question is, when is the mean or median the appropriate measure of center to be used? In the case of the symmetric graph, it makes no difference because they're pretty much equal. So the question is, if it's non-symmetric, which to be used? So in general, we're going to answer this question more in depth later, but the general answer we can give right now is as follows. If it's not highly skewed and no outliers, then use the mean. If it's highly skewed or outliers, then use the median. In terms of outliers, you can kind of think about it. because we know that outliers will significantly affect the mean. One outlier can have a huge impact on the mean, but will usually have a very minor impact on the median. And when you have high skewness, we know the mean is going to be pulled significantly more than the median. So if we have outliers or lots of skewness, it's better to use the median because it's more resistant. And if we don't have a lot of skewness and there's no outliers, then it's better to use the mean, which is will be similar to the median anyway, but is slightly better to the point that it's the preferable measure of center to use. Does that make sense so far? Any questions? Comments, remarks, metaphors, similes, allegories, anything? Okay, so now, we have measures of center. So now it's time for measures of variability. Variability. So this is, let's make it smaller. Okay, there we go. Now it's time for measures of variability. We already have the spread, right? When we talked about distributions, we said there were 4 things that we want to focus on: the shape, the center, the spread, and outliers. The spread was low to high. But low to high is not as precise as what we're looking for. We want a measure of how spread out the data is other than low to high. If I have an example, which I'm going to erase in a second, but if all my data is here with one little guy over there, then the spread is not going to be a very good measure of variability because this guy really has a huge impact on the spread. But this is really where the data is located. So we want to have a measure that kind of ignores that little guy off to the edge, or at least minimizes its contribution because it's insignificant relative to the vast majority of the data points. Does that seem reasonable? So there are 2 basic measures of variability. One is going to go with the mean. The other is going to go with the median. And you don't mix them up. The one that goes with the mean does never, ever go with the median, and vice versa. So does anyone know what the 2 basic measures of variability are? Even though we haven't covered them. I don't even think I mentioned the names yet in the class. But perhaps someone knows just from either reading or possibly taking stats in high school or some
Is
other.
one standard deviation?
One is the standard deviation, and that is going to go with the mean. Standard deviation. Pronounced, I'll usually call it the ST-dev, standard deviation, the ST-dev. And does anyone know the other one? The other one is called the interquartile range, often called the IQR. And we're actually going to start with that one. Okay, so we want to build up the interquartile range from scratch. We want to see how to compute it. Okay, so we're going to start with the IQR. First, we have the range itself. The range is the max minus the min. It's very similar to the spread, which is low to high. But rather than giving me the actual low and the actual high, you just give me the difference between them. It's called the range, biggest to lowest, max minus min. It's a number. Low to high, if I say it's 7 to 12, what's the range if the data goes from 7 to 12? What would the range be? 5, right? The range is a single number, max minus min. The range is 5. Okay, the spread would be 7 to 12. So the spread is actually a little more descriptive than the range itself, because the spread actually tells me my low to high. The range, it could really be anywhere, 7 to 12, 100 to 105, and so on. The problem with the range, as we've already mentioned, is it ignores possible contributions from the far left and the far right that might be outliers. So we want to have a range that's essentially the range of the middle portion. And that's what the IQR measures. It's the interquartile range is giving us essentially the center portion range. And here's how you calculate it. We're going to find 5 numbers. We're going to find the minimum. We're going to find the maximum. Of course, those are easy to find. You can kind of just read them off the data sheet. Directly in the middle, we already have the median. And we're now going to assign the median a new name. It's also going to be what we're going to call Q2, or the second quartile. So later on in the course, we might call it Q2, we might call it the median. It's the same thing. And then what we're going to do is as follows. We're going to take the median of the left side. This is the median of the left. The median of the left. And we're going to call that Q1. And this guy here is the median of the right. And we're going to call that, now this one's tough. Can anyone take a guess of what we're going to call this one?
Q3.
Hey, look at you, you got it, Q3. So we have Q1, Q2, and Q3. So can anyone guess what the interquartile range is equal to? It's a number like the range was, but while the range is max minus min, the interquartile range, on the other hand, is going to be what? Can anyone take a guess?
Q3.
What do you got?
Go ahead.
Is that Q3?
I'm sorry, I heard a couple people talking at the same time. Say that again, please. I'm not saying you're wrong. I couldn't hear it.
Q3.
Just the number Q3? There it is. Q3 minus Q1. The interquartile range, the middle quartile, or the middle 2 quartiles technically, is Q3 minus Q1. That is the interquartile range. And it's a better measure of variability because it's essentially only taking into account, it's giving a lot more weight to the parts in the middle, near the center, near the median, than it does the data points near the edge. And I only want to have one note here that I want to write down. Note, very important. Never include the median when calculating Q1 and Q3. And what I mean by that is when you're calculating the median of the left, you look at all the data to the left of the median, but you don't include the median. You ignore it, just to the left of the median. Median to the left, and I'm going to write in here, ignore Q2. And the median to the right, and I'm going to write in here, ignore Q2. You do not look at the actual median when computing either Q1 or Q3. You look only to the left and right of them. Let's do an example to illustrate calculating the IQR. So there's an example in the book. If you have it with you, I'm looking at page 51, but I'll write it here again because there's not many numbers. 5, 8, 10, 12, a couple 15s, a couple 20s, 25, 30, and then the magic of iPads, a couple 35s, a couple 40s, and a 70. So this is my data. So let's calculate a few things here. First, let's calculate the range itself. What is the range equal to?
Max minus min.
In this case, what is the range equal to? 65. All right, max is 70, min is 5, so 70 minus 5 is 65, correct? Okay, obviously the 5 is the min and 70 is the max. They were very nice. They already gave it to us in chronological order. Had they not done that, I would have had to rearrange it to put it in chronological order, but this one already is. So now it's time to compute the median. How do I compute the median? How do I compute the median? Anyone? If odd, it's in the middle. Great. Well, is it odd? Which 20? This is important. Which 20? Because there's two 20s. So the second 20 is the median. Do we all agree with that?
Yeah.
So you say the average of both. What do you mean by that? Remember, there's 15 data points here. So the median will be the eighth. 1, 2, 3, 5, 6, 7, 8. The eighth one is the second 20. I have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I count 15. Make sure you count the same as mine. Excuse me. So now let's compute Q1. I ignore the median. So I'm going to look only to the left of the median. How many data points do I have to the left of the median?
7.
7. Now, just notice, had I picked the first 20 as my median incorrectly, I have only 6. So I get a different answer. So that's why it's the second 20 that's the median. So when I look at those 7 data points, which one is going to be Q1?
12.
12. And then we also look at the right side. How many data points are there to the right of the median?
7,
7. So which one is going to be Q3?
35,
The second 35.
The second 35 is correct. Now, in the case of Q1 and Q3, it doesn't make a difference which one it is because I'm not going to be subdividing them any further. But yes, it is the second 35. So what is the IQR? By the way, Labeth, you said, or Leabeth, if I pronounced that wrong, you said 8 to how many data points there are to the right of Q2, but be careful, it's only 7. Right, the Q2 itself does not count. So the IQR is equal to 23. Do we agree with that? IQR is Q3 minus Q1. Okay, so now that I have the IQR, I can answer the following very important question. How do I know if a data point is an outlier? How far is far enough to say it's an outlier? It certainly looks like 70 should be an outlier. I mean, that's a big jump from 40. But is it? What's the cutoff? How do I know if a data point is an outlier? So we will use the 1.5 times IQR rule as a guide. So we're going to use the 1.5 times IQR rule as a guide. So the first thing we need to do is, of course, find 1.5 times the IQR. Now, I already have the IQR, it's 23. So to continue our problem, to continue our exercise, let me switch back to red. What is 1.5 times the IQR in our example? $34.5. So here's what we do. Go to Q1 and subtract 34.5. What do we get? Negative 22.5. Go to Q3 and add 34.5. What do we get?
$69.5.
69.5. Anything past those numbers is an outlier. Any data points past these numbers will be considered an outlier. So for our example, are there any outliers? And what would it be?
70.
So 70 is considered an outlier. Of course, it's also right very close to the border of being an outlier and not being an outlier. So I might decide to do a little more investigation. But for the intents of this class, without getting into the real life repercussions of making a mistake, we're going to hold by the 1.5 times the IQR rule to determine if something is or not an outlier. Let's do another example. Again, this is on page 51 in the book if you have it, but if not, I will list the data points again. So we have 10, 10, 10, 10, 12, 2 15s, 2 20s, a 30, 2 35s, a 40, a 45, 2 50s, a 55, a 60, a 65, and a 75. Uh-oh. Okay. And the question is, what, if any, of these data points is an outlier? Now, that's one question to determine if it's an outlier, but it has a lot of preliminary steps to get to the answer to that question. What's the first thing we should do?
Find the median.
Find the median. Yes, we got to find the IQR, but even before the IQR, we have to find the median. So how many data points are there?
19.
There are 20 data points, which means where is the median located? The median is not 30. What between 30 and 35, the median Q2 is equal to
32.5.
32.5, right? Halfway between 30 and 35. Do we agree? Now that we have Q2, now that we have the median, what's the next thing we should find? Q1 and Q3. So we're not going to use 32.5 for either the left or the right. So how many data points are there to the left of 32.5? 10. So which is the median of the left 10 digits? It's not 12.
13.5.
13.5. The median of the left 10 digits is halfway between 12 and 15. Alexis, do you agree? Alexis, do you agree? You there? Hello. Yes. Ooh, very emphatic. I love it. All right. And now where is Q3? So Q3 is 50 because it's halfway between 50 and 50. We all agree with that?
Yes.
So what is the IQR?
$36.5.
36.5. So what is the 1.5 times the IQR? 50 minus 13. Yeah, 36.5. Okay. So what is the 1.5 times IQR?
54.75.
54.75. What do I do with that information? 54.75, the 1.5 times the IQR.
You
Subtract.
subtract.
From what? Well, I don't subtract Q exclamation point.
Subtract Q1 from the 1.5 times IQR.
Close, but the other way around. You
The other way
subtract
around.
1.5 times the IQR from Q1, right? And I don't actually need to do it. I don't actually have to do it. All I have to do is check what? I mean, nothing wrong with doing it. But if my lowest data point is 10, all I care about is this past 10 or not past 10. And just by looking at it, 13.5 minus 54 point whatever is certainly past 10.
It's going to be in the negatives.
Yeah, it's going to be the negative. So I don't actually need to take my time to compute it. I can just look at it and know that 10 is not an outlier. What about the other side?
Add Q2 plus 1.5 times the IQR.
Not Q2, never Q2.
Q3.
Q3.
Sorry.
I forgive you. And when we do that, 50 plus 50 something, I don't actually need to care about the actual value, but rather what?
If the 75 is an outlier,
Right. But is it or not in this situation?
no.
No, because 50 plus 50 something is 100 something. So therefore, there are no outliers. Right. So this is greater than, this first one is less than 10. The last one is greater than 75, and therefore there are no outliers. Do we agree with this?
Yes.
All makes sense? Okay. So as a follow-up to what we did, we have something called the 5-number summary. The 5-number summary is just the following 5 numbers. Can anyone guess what those 5 numbers are that in some sense summarizes the data?
Q1, Q3, the median, and the lowest and highest value.
Yes, excellent. Very nice. So the 5-number summary, the 5 numbers that summarize the data are the lowest, the first quartile, the second quartile, the third quartile, and the max. And we have a visual display. So this will be our third quantitative display. Someone remind me, I forgot. What are the first 2 quantitative displays that we've had for quantitative data? Stem plot
Histogram.
and histogram. So this will be the third one, called a box plot. And I'm going to illustrate it using the previous example. So the minimum is 10. The maximum was 75. So 10, 20, 30, 40, 50, 60, 70. Let's move it over here. So we're going to plot the minimum and maximum with dots. We're also going to plot Q1, Q2, and Q3, but these get vertical lines. So 13.5 gets a vertical line. 32.5 gets a vertical line. 10, 20, 30, and 50 gets a vertical line. And then we make a box like this. So we have this box. And then we have these, sometimes people will actually, so it's easier to see, will actually draw them not on the number line so that you don't confuse the number line with the box plot itself. I probably should have, but then I just didn't. And here's the thing about the box plot. We want to interpret the box plot correctly. This guy here, this value is what? What is that point right there?
Q2,
That's Q2. And what is this one over here?
Q1,
Q1. And this guy here,
minimum,
that's the minimum. And this one here,
Q3,
that's Q3. And how about over here?
maximum,
That's the maximum. But let's remember what these three, all these things do. The median is the halfway point, which means half the data is to the left and half the data is to the right. The median of the left side, Q1, means half to the left, half to the right, which means in this section between the minimum and Q1 is approximately 25% of the data. And between Q1 and Q2 is approximately 25% of the data. And from Q2 to Q3 is approximately 25%. And from Q3 to the max is approximately 25%. So what the box plot does is it essentially helps us visualize a separation into each 25% grouping of data amongst our data points. Based upon this, would you say this is a skewed left or a skewed right or a symmetric graph?
Skew to the right.
This is skewed to the right. Very good, because if you look at the rightmost 25%, the rightmost 25% has really a drawn out what's that? The rightmost 25% is has a very lengthy, in comparison to the rest at least, a very lengthy range of values, which means we have a lot over there, and it really stretches. This is something that might look like this, where I might have 25% and then 50% and then the remaining 25%, something like that. I'm not the greatest artist in the world, but hopefully the general idea is coming across, where you can tell by the box plot, or at least you can get a general idea of whether it's skewed left or skewed right, or if it is symmetric. Does that make sense? Any questions so far on anything we've done? All good? Okay, so now we're going to go one step further and talk about a modified box plot. I.e., what to do if there are outliers. So we know what a box plot is, and now the question is, what do we do if there's some outliers? So to that end, let's use the example that we had a few minutes ago, where we did have an outlier. It was this one here, correct? I believe 70 was an outlier, correct?
Yes.
So what I'm going to do here, well, I don't have to copy it, but let's try to remember. 5, 12, 20, 35. Well, you know what? I'm going to do the following. I'm just going to do this, duplicate. All right, so here's the example from before. So let's make our regular box plot, not our modified. Let's do our box plot first. So here's my number line. And here's 0, and we want to go up to, let's say, 80. So 0, 10, 20, 30, 40, 50, 60. Hey, that wasn't bad. So let's make our box plot. Where should I put the first element of my box plot? And what should I put there? Anyone?
The 2. The
Sorry?
median.
I didn't hear this. Say it again.
The median.
What's the median? I'm not saying you're wrong. I'm just asking for clarification. What's the
20.
median? 20. And what should I put at 20?
A vertical line.
Okay, so we get a vertical line at 20. Okay, what's next?
Q1, which is 12.
And what should I put there?
Also a vertical line.
Also a vertical line. Okay. What else we got? Minimum. What should I put there? A dot. And where is the minimum? At 5. Okay. Let's fix that a little bit. Okay, what else we got?
Maximum,
Maximum. Where's the maximum?
70,
What should I put there?
a dot,
Dot. Okay, anything else?
Q3.
35,
What should I put at Q3?
A vertical line.
A vertical line at the 35. And now how do I finish the box plot?
Connect the 3 vertical lines.
Okay. Is that it?
And fill in the rest from Q3 to the max.
Okay, so this is my box plot. So we then determined that this guy here was an outlier, correct? So because we have an outlier, we're going to modify it. We're going to make a modified box plot. And here's how we modify it. What we do is we don't include the outliers, at least not quite yet. We ignore the outliers and put a dot at the last maximum that was not an outlier. What was the last maximum that was not an outlier?
40.
40. We put the dot at 40. And then what we do is we just put a little star at the outlier's location. Everything else is exactly the same. Let's move it over a little bit. Yeah, there we go. Everything else is exactly the same. So the difference between a box plot and a modified box plot is that a modified box plot really recognizes that outliers change your display considerably. And therefore, as a result, we kind of ignore them, but also include them at the same time. Does that make sense? Are there any questions on anything done so far?
Yeah, Professor, can you just clarify that again?
Which part?
So the line, I guess you could say, is to 40, and you're saying we don't include the outlier, but like we do that part.
Well, so we include the outlier with a star, but we don't include it as the maximum anymore.
Okay.
So we go up until that point, up until the largest value that's not an outlier, and we treat that like a maximum. And then we just put a little star by the actual outliers because we don't want to pretend they're not there, but we don't want to consider them as maximums either.
Okay, that makes sense. Thank you.
You got it. Okay. Anyone else have any questions so far? Okay. So everything that we've done so far today in terms of this box plots and quartiles and interquartile ranges, the 5-number summary, finding outliers, all of these have been a measure of variability that we use when dealing with the median as our measure of center. Because the very first thing I said is that the median goes with the IQR. Well, what if instead we are using the mean as our measure of center? So if you're going to use the mean as the measure of center, it's a completely different measure of variability that's got nothing to do with all of this box plot stuff. So now, what if the mean is the appropriate measure of center. So we've already entered this. We will use the STDEV, the standard deviation. And how is that defined? The definition is not the simplest, but once you get the hang of it, it's not that hard either. And of course, your calculator can do it for you, which makes it all the better. So given data points, x1 through xn, first compute x bar. Someone remind me, what was x bar referring to again?
The mean.
The mean. First compute the mean. And then compute all deviations from the mean, i.e. D1 is x1 minus x bar, deviation 2, x2 minus x bar, all the way through deviation n, which is xn minus x bar. So for every one of your data points, you're going to subtract the mean from it. Some will be positive, some will be negative, but in general, you'll have all of your data points. S squared, called the variance, is equal to all of the squares of the deviations added together divided by n minus 1. So after you've computed all your deviations, you're going to square them all, add them all together, and divide by n minus 1. S, which is the standard deviation, the STDEV, is then just a square root of S squared. It's a square root of the variance. Technically, this is called a sample variance and a sample standard deviation, not to be confused later in the course with an actual variance and an actual standard deviation. Whenever you have a sample of data points, you're going to use that to find your sample variance and your sample standard deviation. Let's do a quick example by hand, and then we'll do the same thing with a calculator to show how much easier it is with a calculator. So let's first do it by hand. So a simple situation, your data points are the values 490, 580, 450, 570, and 650. So these are my data points. What's the first thing I calculate?
The mean.
The mean, x bar. How do I calculate the mean again? I forgot.
Add all the numbers together and then divide by how many numbers you have.
That's right, right? Add all the numbers together, then divide by how many data points we have. You should have your calculator with you, or since you're at the computer, you can always use Desmos or something like that, but you should be able to follow along. What do we get?
$548.
548. Now, let's find our deviations. So what is deviation number 1? What is deviation number 1?
Negative 58.
Negative 58. What is deviation number 2?
Is it 32?
32. What is deviation number 3?
Negative 98.
Negative 98. Good. What is deviation 4?
22.
22. And finally, what is deviation 5?
102.
102. And just for fun, by the way, if you add up the 5 deviations, what do you get? Even though it's not part of our process, if you do add them all up, what do you get?
Is it 0?
Did you do that? Or did you figure out it had to be 0?
I just did it.
Okay, that's fine. It does add to 0, and it will always add to 0, which is why in our formula for the sample variance and the sample standard deviation, we don't just add the deviations because you'll always get 0. There's 2 ways of getting around this. The reason why you get 0, some are positive, some are negative, you're going to have a cancellation effect. So by squaring them, you make them all positive. Now we don't have a cancellation effect. What's the other way I could have done it to not have a cancellation effect? Besides squaring them all. How else could I have got rid of the negatives? Who knows their math? Besides squaring, how do you turn negative numbers positive?
Absolute values.
Absolute values. But the reason why we don't use those is because from a mathematical standpoint, absolute values are much more difficult to work with than squaring. I know this is not a calculus-based class, so we're not going to do any calculus this semester, but squaring, calculus can handle easily, and you need calculus to do pretty much any advanced math. Absolute values, much more challenging. So we use squaring because its properties are better because of what we can do with it. Either way, now that we have all these deviations, we need to square them all and add them all together. So when I square them all and add them all together, what do I get just by that part? What is d1 squared plus d2 squared plus d3 squared plus d4 squared plus d5 squared equal to? What do I get when I add the squares of all 5 of these numbers? Anyone?
Is it 24,880?
24,880. So after adding these numbers together, what am I going to divide by?
4.
4. And what do I get?
$6,220.
6,220. And therefore, if I want the sample standard deviation, what do I do to that number?
You square it, and then do the square root of it.
Square it and square root? Won't they cancel each other out?
Yeah, sorry, I meant square root.
And what do I get when I do that? Anybody? What do I get when I do that? 78.86, 78, yeah, approximately 78. Let's say 78.9. Approximately 78.9. So that's how you do it by hand. Does anyone here want to do these by hand? No, nobody does. Not in the history of the planet. So we will do it now, or we will do it now on my calculator. So I'm gonna stop sharing for a second. So hopefully you can all see this. Am I big or small right now? Am I pinned? You guys all see a big me or no?
Yeah.
Okay. So what we're gonna do is do the same thing on the calculator. The first thing you're gonna hit is the stat button. Usually when you use statistics, you're gonna go into stat mode. So stat. And when you do that, when you do stat, you'll have edit, calculate, tests. You wanna click the edit button, so enter. And it should take you to a screen that looks like this. Now I already have some data on mine that I wanna get rid of because we're not gonna use that. So what I'm gonna do is I'm gonna go up to the heading, in this case, L2, hit clear, and then go to L1 and hit clear. So all my data is now gone. Okay, so now I have no data present. And what I'm gonna do is I'm gonna put my 5 data points in the L1 column. So what were my data points again? My data points were 490, enter, 580, enter, 450, enter, 570, enter, 650, enter. So at that point, my calculator looks like this. Does that make sense so far? Have I gone too quick to follow? Are you guys all with me? Okay. At that point, you're gonna hit stat again, taking you back to here. But this time, we're not gonna edit. We're gonna go to the right, and we're gonna go to calculate. And we're gonna have all of these different possible calculations that we can do. And the one that we're gonna do is the very first one, var stats. So you're gonna hit enter on the very first one. It's a 1 variable stat. So you're gonna hit enter. And it's gonna ask you which list you're using. We're using L1. And it's gonna ask you the frequency list, which we're gonna ignore. And then it's gonna say calculate. And you hit enter each time and you get all this data here. Which one are we looking for?
SX.
FX, right? So SX, the standard deviation of the X data, 78.866, yada, yada, the same thing we got the other way. Also notice, by the way, it gives you X bar. It gives you the min. It gives you, if you look a little lower, look at those numbers in the bottom. What do we have there? We have the 5-number summary, Q1, the min, the Q1, the median, Q3, and the max. We don't use them for this. We only need SX, but we get it all there. Do we all see that? So that's a little bit easier. Is there another way we can do it? And the answer is yes, there is. And for this, I'm going to share my screen. And I'm going to go to Canvas. And let's take a look. It should be, how do I get to the, oh, actually this is, okay, never mind. I'm gonna use this one here. This is the Macmillan thing. And I'm gonna go into the course. And I'm gonna see something somewhere. I should see it. I don't see it. Maybe resources, is it there? I should see something called crunch it. I don't see crunch it. Do you guys see crunch it? Do you guys ever see crunch it when you were here? Hold on a second.
You can like see it if you go into the homework.
Into the, in the homework, okay. Okay, so if I go into the homework, yeah, do I gotta go into one of the questions?
Yeah, some of the problems have like a link to go to crunch it. It like one with like a data set.
Okay, but there should be a way of getting there straight, but for now,
Question 4.
I'm sorry?
One of them is on question 4.
Question 4, okay. So, okay, here we go, crunch it. There should be a way of getting there directly. But either way, if you can get into crunch it, which is a very amazing program to use. Okay, so we're going to delete selected. Nothing selected. Okay, never mind. We're going to, let's see, how do I delete everything? Let's see if I can delete selected. Okay, there we go. Delete selected. Okay, so it's kind of like a, let's say delete column, delete column. Okay, so we have nothing here. So here we're going to do a new. Okay, so on crunch it, I'm going to put in, okay, double click a cell. I'm going to put in 490 and 580 and 450 and 570 and 650. And this is on variable 1. So we got to find the right one. We're not looking for a box plot or a stem and leaf or a histogram, right? These are all things that we've seen some of. We're trying to do some actual math. So let's see. I got to find it. I haven't used this in a while. So let's see. Frequency table, maybe? No. Where are you? No, not here, not here. Maybe it is. Where is it?
Is it under distribution calculator? Oh wait, remember now.
I don't think so. No, that comes later in the course. And it's not like a box block. That would be, let's see, I always thought it was, well, let's see what happens. Let's calculate. Oh, okay, there it is. So it was under descriptive statistics. Just to recap what you got to do, you put it in. Statistics, descriptive variable 1. You got to tell them which column you're looking at. Then you hit calculate, and you see it gives you the sample mean, 548, and the same sample standard deviation that we got before, 78.9. So you can use crunch it. I would recommend using this for homework for 2 reasons. One, it really is straightforward once you know what you're doing. And it's always linked to the homework, so it's very easy to access it. However, the calculator is very handy because on your final, you're not going to have access to crunch it, since your final is on campus and you can't use your computers. And of course, you can do it by hand but who would really want to do it that way? So yeah, so we have crunch it, and we have your calculator, and we have doing it by hand. So are there any questions so far on anything that we've done?
Do we have to include the number in the data sets for both the median and the mean when doing the 5-number summary?
The mean plays no role in the 5-number summary. The 5-number summary is purely a median IQR result. So the mean never pops up. What calc do I recommend? If you're going to get a calculator, the TI-84 Plus CE is my personal favorite when it comes to statistics. I have that calculator, and I also have a very different kind called a Hewlett-Packard calculator. But this one is I don't use this for stats because it's not nearly as good. If you're going to get a calculator and you want to go through life with a calculator, the TI-84 plus CE. And just so you know, I do not get any, kickback by recommending it. So it's not my own personal, it's not for me. It's for you. And it's very important. Any questions on what we did today? So we have finished chapter 2. I went kind of well, I thought. What do you guys think? Did you guys feel like it made a lot of sense and it's fairly straightforward?
Yes.
Well, that's good. According to the sample syllabus that is on the sample timeline for the course, on the syllabus, it basically expects us to finish chapter 2 by this Thursday. So we're kind of like already a full day ahead, which is wonderful. But we're not going to go on Thursday. What I want to do on Thursday is go through the workbook that we have and do problems on there. So we're not going to, now if we finish early, maybe we'll start chapter 3, but we might not. But other than that, I think we threw a lot at you right now, and I think it's a good time to stop. What do you guys think? See, that was a test. You all failed. You all should be saying, no, I pay for this course. I want to learn more. Wow, you all failed. Incredible.
We learned what we needed to learn in
Oh,
the
did
time
you?
we needed
Oh,
to.
did you? So you're done. You don't got to learn anything more. That's fine. I'm tired anyways. My throat's hurting. So I start teaching at 8 o'clock in the morning on Tuesdays and Thursdays, and I go till 8 o'clock at night. So I wouldn't mind. Time to take a nap. Yes. Yes. All right. I'm going to stop recording.